What we're going to look at today is how to use the law of sine within applications. So what that means is we're given word problems and we have to use the law of sine in order to figure out our missing components. Whether it's an angle or a side, it remains to be seen. But first, we have a little exercise here. For our first problem, we have to use this triangle here to find the lengths of AC and AB. Now again, the law of sine is a proportional relationship. It says side A over the sine of angle A is equal to side B over the sine of angle B, which is equal to side C over the sine of angle C. Now, in order to do that, we need to know 3 out of the 4 pieces of information. So we have 2 angles and side BC, but we don't have side AC, we don't have side AB, and we don't have angle A here. So we need to do a little sleuthing here. Fortunately for us, triangle is set in stone where all 3 angles add up to 180 degrees. So if I know 2 out of the 3 angles, I can easily find the third angle by subtracting the 2 angle measurements from 180 degrees. So we're starting at 180 degrees, and we have to subtract the 52 degree and 74 degree angles, which means angle A is 54 degrees. So now we can use the law of sine in order to find our 2 missing pieces. Here we have angle A, which means here we have side A. Here we have angle B, so missing side would be side B, angle C, and over there would be side C. So it really doesn't matter which of the 2 sides we find first, because we're going to end up doing the same thing twice anyway. So I tend to go alphabetically, so we'll find side B first. So side A is 3.31 over the sine of angle A, which is sine of 54, is going to equal side B over sine of 74. And what we'll do is we'll cross multiply here. We have 3.31 times the sine of 74 is equal to B times the sine of 54. And what we're going to do is divide by the sine of 54 on both sides. What this does is the sine of 54 will cancel out, leaving us with just B equals, and then in the calculator we'll do that. But first thing, because we are dealing with angle measurements of degrees, we have to make sure we're in the correct mode. Notice I'm in radian mode. I'm just going to go over to degree, hit enter, and we can quit out of there. So 3.31 times the sine of 74 divided by sine of 54. And we get 3.6833, and it says round to the nearest tenth, so 3.68, we round up to 3.7. And that makes sense because 54 is smaller than angle 74, so B should be a little bit longer than side A. And now what we're going to do is we are going to do side C. So again, now that we know the 2 measurements, we're going to be able to use either A or B. Now we use side A and angle A in the first, so we might as well use the same. So again, 3.31 over the sine of 54 is equal to side C, our unknown, divided by the sine of 52. Cross multiply, so we have 3.31 times the sine of 52 is equal to side C times the sine of 54. We'll divide by sine of 54. This cancels out on the side with C, and it leaves us with just C. And we can use our calculator now. 3.31 times the sine of 52 divided by sine of 54. And we get 3.22, so round to the nearest tenth, 3.2. And again, it makes sense because angle C is the smallest angle, so side C should be the smallest side as well. So everything looks good, everything makes sense, and we can move on to what an application actually looks like. Here we have two lighthouses 30 miles apart on each side of the shore, running north and south as shown. We have a keeper at both lighthouses, and they both see the boat off in the distance. One lighthouse keeper notes the location of the boat is 40 degrees east to south, and the other light keeper marks the boat as 32 degrees west of south. What is the distance from the boat of the lighthouses at the time it was spotted round to the nearest mile? So what they did for us is they drew us a nice little picture. This makes our life a little bit easier. So here we have the two lighthouses and the boat off to the distance here, and we are told straight off this way and towards the other lighthouse makes a 90-degree angle from both lighthouses. Now, we are told this angle measurement here is 40 degrees. And this angle here is 32 degrees. So in order to be able to use the law of sine, I need to know the measurements of the actual triangle itself. So the triangle is formed by the two lighthouses and the boat. The only thing I have in terms of measurement within this triangle is the 30 miles. But fortunately for us, they also gave us the hint that we have 90-degree angles created by the lookout from the lighthouse and out. So if this part of the right angle is 40 degrees, the rest of it is going to make up 90. So 90 minus 40 means this angle is going to be 50. And I'm going to do the same thing with the other angle. We are told this part of the angle is 32 degrees, and the rest of it is going to get me to 90 degrees. So 90 minus 32 means this angle is a 58-degree angle. And once again, once I know 2 out of the 3 angles of a triangle, I can subtract them from 180. So I can do 180 minus 50 minus 58. So 180 minus, in this case, it's going to be 108 degrees. Means our last angle, 180 minus 108. Touchy today. 180 minus 108. Means this angle here is 72 degrees. So now I know the 3 angles, and I know one piece of information. The 30-mile distance between the 2 lighthouses. Now all I have to do is figure out the distance between lighthouse 1 in the boat and lighthouse 2 in the boat. So we can use the law of sine here in order to figure it out. Now in order to figure out the law of sine, we definitely have to use our 72 degree and 30 miles. And we can use any one of the other angles to find our missing piece. So law of sine, again, is A over sine of A is B over sine of B, which is C over sine of C. And we're only going to use 2 out of the 3 here, and we definitely have to use 72 degrees, and we definitely have to use 30. So 30 is the length of a side over sine of 72. And that is going to be equal to, and again, it really doesn't matter which one we use, B, and we'll use, say this is lighthouse 1 and lighthouse 2. So we'll use angle measurement of 50 in this case. So sine of 50. We'll cross multiply. B times the sine of 72 is equal to 30 times the sine of 50. And we can now divide by the sine of 72 in order to cancel out on the side with B. So now all we do is 30 times the sine of 50 divided by sine of 72. 24.16, so round to the nearest mile, 24 miles. So that means the side across from 50 degrees is 24 miles. And now we get to do it again, only this time instead of using 50, we're going to use 58. So We'll use our original numbers, 30 over the sine of 72. It's going to be equal to, and now we have to use our unknown side. So we used b last time, so we'll use c this time, over the sine of 58. Cross multiply, so c times the sine of 72 is equal to 30 times the sine of 58. Now we can divide by the sine of 72. It'll cross off, it'll cancel off on this side, and we have c equals, and now all we have to do is 30 times the sine of 58 divided by sine of 72. Gives me 26.75. It says to round to the nearest mile, so we have to round up to 27 miles. So from Lighthouse 1 to the boat is 27 miles. So now we have our three measurements between our lighthouses and the boat. Lighthouses is 30 miles, and then Lighthouse 1 to the boat is 27 miles, and Lighthouse 2 to the boat is 24 miles. Now number 3, we have a ship captain at sea using a sextant to sight an angle of elevation of 37 degrees to the top of a lighthouse. After the ship travels 250 feet directly towards the lighthouse, makes another sighting, and the new angle of elevation is 50 degrees. Ship's chart shows that there are dangerous rocks 100 feet from the base of the lighthouse. So find to the nearest foot how close to the rocks the ship is at the time of the second sighting. So this one's going to take a little bit of work. So here we have a ship at sea. So again, angle of elevation means we have a horizontal line of sight with an angle of elevation of, in this case, 37 degrees. And then he travels 250 feet, and we get an angle of elevation of 50 degrees. So we're just going to extend that a little bit. Best we can. There we go. We'll say that's a triangle. So first sighting, we are told we have an angle measurement of 37 degrees. Second sighting, we have an angle of elevation of 50 degrees. And from sighting 1 to sighting 2, we have traveled 250 feet. Now over here we have a lighthouse. And from 100 feet from the base of the lighthouse, there are some rocks. So from here to the lighthouse is 100 feet. So we need to know how close we are to this spot right there at the time from here. So from 2 over to here, we have unknown x. So here, yeah, I gotta make my lighthouse a little bit taller here. So here's our lighthouse. So notice we have two ginormous triangles here. We don't know how tall the lighthouse is. We are told that we have angles 37, 50, 250 feet between sightings 1 and 2. There's 100 feet between the rocks and the lighthouse, and an unknown distance between our second sighting and the rocks. So what we need to do is find that unknown sighting in order to figure it out. Now we do know that here we have a 90-degree angle, which means if this angle down here is 50, this angle is 90, that makes 140 degrees, which means this angle up here has to be 50 degrees as well, or 40 degrees. So 50, 40, 90 makes 180 degrees. And we also know with a horizontal line of sight that if this angle is 50, to get the rest of it, we subtract from 180 as well. So 180 minus 50 means this angle here has to be 130 degrees. So what we now have is two measurements out of the smaller triangle. So 37 and 130 makes 167. And to get to 180 means this angle up here is only 13 degrees. So what we can do is we can use all these pieces of information in order to figure out our unknown x. So first thing I need to know is just how far is the top of the lighthouse from sighting 1. Sighting number 1, we're going to use it because we have this bit of measurement. So we have a side, we have the angle across from it, 13 degrees. And we also have the angle measurement of 130, which means I can find our hypotenuse here, which is going to help us out in the long run. So we're going to use the law of sine here. So side A, the one that we do know, is 250 feet over the sine of its respective angle, 13. Is going to be equal to, and I'll use side C because it's a hypotenuse, so side C over the sine of, in our case, 130. So we're going to cross multiply here. We have 250 times the sine of 130 is equal to C times the sine of 13. So we're going to divide by the sine of 13. And what we get now is C equals, so 250 times the sine of 130 divided by sine of 13 gives me 851.34569. So to the nearest foot, we're talking 851 feet. So now what we can do is use it to our advantage in order to figure out what exactly we're looking at. Now, in order to do this, what we need to do is we need to see, we got 851, we have its respective angle, 90. We have angle measurement of 40, and we have x and 100 feet. Now the problem is I can't do x plus 100 times the sine of anything because it make life difficult. However, we do know just exactly that we have a large triangle. We have an angle measurement of 37 degrees here for this larger triangle as well. So 37, 90, and then here we have 13 and 40 making 53 degrees. So what we can do is we can say this whole thing is an unknown as well. So we'll label that as y. So what we can do is use the 90-degree angle and the 851 feet, and we can use the 53 and the full length unknown. Because once I know what this is, notice I have 3 pieces. All I have to do is find the missing piece to get to the full length. So here we have 851 feet over the sine of 90 is equal to our long unknown side y over the sine of 53. And again, we're going to cross multiply. So we have 851 times the sine of 53 is equal to y times the sine of 90. So what we're going to do is we're going to divide by the sine of 90. So 851 times the sine of 53 divided by sine of 90 gives me a full length of 679.6, so we'll round up to 680 feet. So we know the full length across from sighting 1 to the lighthouse is 680 feet. However, we're just trying to figure out how far we are from the rock. So from sighting 2 to X. Well, from sighting 1 to sighting 2 is 250, so we don't need that. And from the rocks to the lighthouse is another 100 feet, so we don't need that as well. So we're just going to take away those two measurements from 680 feet. So the last thing we need to do is 680 minus 250 minus 100. So we are now 330 feet away. So that's going to equal X. So 330 feet equals X. So from sighting 2 to the rocks ends up being 330 feet. So in some cases like this, you need to make a large picture and you need to think a little outside the box in order to figure things out. So yes, it looks like we're going to be dealing with two separate triangles. However, we ended up dealing with just this smaller triangle on the left and the larger triangle overall from site 1 to the lighthouse to the top of the lighthouse. And last but not least, we got a young tree braced by two wires extending in straight lines from the same point on the trunk of the young tree to points on the ground on opposite sides of the tree. Wires are fastened to stakes on the ground 64 inches apart, making angles of 35 and 40 degrees with the ground. To the nearest inch, how far up the tree are the wires connected? So again, we have to draw a nice little picture. So here we have a nice little tree. And at the same point on the tree, we have two wires. So we'll say there's a wire, and here we come down, and then over there is another wire, and it comes down to the ground. Now here we got the ground. And yeah, it can be a little nicer, but so there's wire, and fortunately for us, what they tell us is on the ground here where it's sitting makes a nice little triangle, and we are told the angles are 35 and 40 degrees. And we are told that the stakes are 64 inches apart. From stake 1 to stake 2 is 65 inches. So how far up the tree are the wires fastened? So that means we need to figure out from here down to the ground is our unknown X. So how are we going to do that? Well, fortunately for us, we have a nice big triangle from stake 1 to the point to stake 2 and between the two stakes. Now this angle is 35, that angle is 40, and we are told that because that's 35 and that's 40, then that means this angle must add to 180 degrees. So 35 and 40 make 75. 180 minus 75 means this is going to be a 105 degree angle. So now we need to figure out just exactly what the lengths are. Now we can do this a couple different ways. We can use the law of sine to find one side, and then we can use it to find the other side. And because we're dealing with right triangle here, we can use the Pythagorean theorem to find the missing side, which is actually probably what we have to do, because we don't know for sure. Well, it is a right triangle, so makes a right angle with the ground. So 35 and 90 means that we have 125 degrees. 180 minus 125 means this part up here is a 55-degree angle. So this is a 55. And then we know for a fact 40 and 90 makes 130, which means this has to be 50 degrees over here. So there's a couple different ways. We could do what I just said. We could use the law of sine to find the lengths of the two stakes and then use the Pythagorean theorem to find the missing side. Or what we can do is we can use the law of sine to find the side over here for from stake 1 to stake 2 and go from there. But we'll do it the first way I said. We're going to use the law of sine to find the lengths of the stakes. So law of sine states 65 inches over the sine of 105 is going to be equal to, in this case, we'll do this side is side x and this is side y. Side x is going to be over the sine of 35. So we're going to cross multiply. We have 65 times the sine of 35 equals x over the sine, not x over, equals x times the sine of 105. So what we have to do here is we have to divide by the sine of 105, which will cancel out and leave us with just x. And we can divide 65 times the sine of 35 and divide it by the sine of 105. Giving us a length of 38.597. It says to the nearest inch, so we're going to round up to 39 inches. So this side is 39 inches. And I get to do the same thing for the other one. So we'll use the same measurement of 65 in relation to the sine of 105 is equal to now side y over the sine of its respective angle, which is 40. Cross multiply. And then divide by the sine of 105. That will cancel out, leaving me with y. And then divide 65 times the sine of 40 and divide it by the sine of 105. And that gives me 3.99, so we're going to round up to 4. Oop. Hold on, 65 sine 40. Divided by sine of 105. 43.25, so round 43 inches. That makes a little more sense. So 43 inches for y. Now, the problem is, in order to use the Pythagorean theorem, I needed to have a, I need it to be a right triangle. So the big triangle is definitely not a right triangle with angles of 35, 40, and 105. So I actually have to use the law of sine one more time. I need to figure out how far it is from one of the stakes to the tree. Now we can do this because we now know the length of one of the sides. So we can use the law of sine for either way, and we can we can actually use it to find our missing side. So we can use the law of sine to find our missing side because we have the right angle, so we know the angle measurement and we know the side measurement. So we have that relationship to use the law of sine. And in proportion, we have the angle and the missing side. So we can use it one more time in order to find our missing side. So again, it doesn't really matter which side we use, X or Y. So I'll just use X since it comes first in the alphabet. So side X, which is 39, over the sine of its respective angle, which is 90, is going to equal our unknown side X over its respective sine of angle of measurement, which is 40. So we have 39 sine of 40 equals X times the sine of 90 after we cross multiply. So once we divide by the sine of 90, we're going to know how far up the tree we got. So 39 times the sine of 40 divided by sine of 90 gives me 25.06, so round to the nearest inch, 25 inches. So here we have 25 inches is equal to our unknown X. And that is using the law of sine within word problem applications. Sometimes we have to draw a picture and do a bunch of work like we had to in number 3. Number 4, also we had to do a little bit of work and sleuthing in order to figure out our unknown angle. So that is using law of sine within application word problems.